All right, thanks everyone for being here, and thanks Ripple for putting in a really fantastic group of speakers together. And just in the first handful this morning, one of my colleagues and I were remarking that it's a really high quality bar compared to a lot of the conferences and get-togethers we've seen in the space so far. So I'm excited to hopefully add to it a little bit. Again, we are from the gaming industry. I've been personally working in gaming for a little over a decade, mostly on the technology side, the tech and tools that game developers use to create their games and to operate them. So some of these are kind of adjacent technologies like data storage, query systems, analytics, and whatnot. Yeah, we have a pretty interesting group of founders that put this effort together. One of them's Kevin Chu, who's super famous in this building, I think, and yeah, a handful of others that are deeply experienced with running games and the needs of game developers. So we are building platform tech to basically try and get game economies initially and incrementally on blockchain infrastructure. And so I'm going to talk a little bit for the first roughly half of the talk about our motivations for doing that, what kind of impact we think it'll have on the way games are run and the way players behave in these game economies. And then we're going to talk a little bit about some of the more hopefully academically interesting stuff related to how we think about trying to build a network that's really performs well, is really robust, and will survive in serving game economies for the long term. So yeah, we're going to talk about token bonding curves. We're going to talk about a framework called Presto that some of you may be familiar with. Not our work, but we think a really good approach to evaluating the merits of protocols. And then we're going to get into some of the again, more I think academically interesting approaches we're taking to trying to figure out how to make our own network and these game economies perform in a really robust way. So there'll be some math, but we'll probably take the deeper stuff offline. Okay, so why do this? Games have grown really incredibly rapidly over the last couple decades. It's a huge industry now. It's worth over $100 billion a year in revenue, and it's been through a whole bunch of different big changes that impact the way people make games and operate them. To kind of note a few, the internet had a huge impact on the way games are distributed. It kind of unlocked game developers distributing their products digitally directly to consumers. Social platforms made distribution much less expensive and introduced some much more value to viral designs. And the free-to-play business model, which you guys are probably all familiar with, or just as like freemium monetization broadly, totally dominates the way games are run now. So there's still a sizable sector of the game industry that monetizes through $60 box products and kind of smaller size downloadable like DLC packs. But for the most part, free to play has grown the games industry more than any other business model in the last 10 years. So looking at the way free to play's evolved over the last decades, really it's a big part of our motivation in exploring what blockchain can do for game economies, because these game economies have gotten, the bar, if you're going to build a game today, requires that you build a very, very deep and by necessity complex economy, because you got a whole bunch of agents interacting with it, and the ones that perform the best, they offer multiple modes of progress. So you might enjoy kind of PvP, put me in a space with 12 other players and let's see who can shoot each other the fastest and the most times. Or it might be totally different. You might be into farming or economy management or exploring the world. So game designers have to account for all this. And if you play any modern like PC MMO or even a lot of mobile games now, you see a lot of this complexity under the hood. And it's, having been on the authoring and operations side of these game economies, I can tell you it's always been hard, and it's harder than ever now. And I think it's actually reached a place where most game teams, even with a lot of resources, struggle mightily to balance these economies and make them perform well, make them perform in a way that doesn't introduce a lot of kind of cognitive overhead and dissonance for players. Because these economies are, they're required to be designed with all the possibilities ahead of time, and to be managed in real time as you've got a big player base interacting with them, interacting with each other, and trying to figure out how to make progress the fastest. And there ultimately are exploits in most of these game economies that you'll see kind of operating just inside the constructs that the game developers came up with in the first place, but just in a way that wasn't expected, or leaving the game economy and sort of subverting what the designers intended with black market, secondary market, account trading. So we're seeing free-to-play kind of hit these limits for really many years now, and for game developers, it's in a sense, it's kind of brought us to a design plateau where it's so difficult to operate these that it's really limiting the other aspects of what players want out of new game designs. So this, by the way, this crazy graph that is pretty hard to read is from a game called Destiny, which is several years old now, but one of the first. It's actually one of the first console games to build a reasonably complex economy that would, has kind of easy to map onto the way most free-to-play MMOs design systems for progress. So, how many of you guys know what this image on the right's from? This is Venezuela about 4 or 5 months ago, and this is kind of illustrative of our thinking about the difficulty and challenges in running a game economy, where you have to figure out in advance what do players want, how much of it do they want, when do they want it, and what tools do you have available to correct an economy being out of balance, to correct people not getting what they want out of the economy. And this is kind of some Econ 101 stuff, or even high school. You learned about the degrees of, this is from Khan Academy, this video, I think, on the spectrum of ways to run an economy, from, typically nation states determining almost everything about what consumers want, what they're willing to pay for it, what supply flows where, and much freer economies that have more developed and rapidly integrated signals from the market to determine, what these updates and balance adjustments should be. So, in 2019, we're seeing some games attempt to embrace this by taking on the risk and the difficulty and the expense of being middlemen for virtual items in game economies that are big and justify the effort and the risk. So on top you see this is World of Warcraft and Eve in the lower slide. These are both really good examples of very long-lived game franchises that have very deep economies. They've kind of weathered many different evolutions of player taste and what players want out of these economies, and to some degree have tried to facilitate marketplace-like activity inside the game explicitly, or to kind of support it externally, and do it in a way that's regulatory compliant and resolves the risk and difficulty of making sure customers have a good experience. So if you end up with a lot of fraud in these markets, and that's why most of the game publishers choose not to build this stuff, is really addressing the counterparty risk and ensuring customers kind of get what they want is a very tall order. And so these are, especially Blizzard, one of the best resourced game developers in the industry, and one of the widely regarded as operating games with the highest level of sophistication. And they have tried and stumbled multiple times in operating markets around some of their biggest franchises. So if you look at what they do now with something called the WoW token and gold, they basically do all the market making themselves. They set prices per region, and they update these on a weekly basis. And so they take on all that risk in addition to acting as a middleman for parties finding a coincidence of wants. So our big thesis and motivation is, can we get game economies to run in a freer way where markets can correct themselves a little better, and where game developers, the teams running these game economies, can see and get more direct feedback from the market to assist in balancing and managing these economies. So we think the blockchain makes a lot of this much more accessible because it's less expensive to deal with some of the really difficult pieces like counterparty risk. You can kind of ride on the back of this trusted value and compute infrastructure and build marketplaces on top of that in a way that doesn't get you all the way to the finish line, but it kind of saves you a lot of cost versus what Blizzard and Eve and some other game publishers have done in the past. So yeah, well, this is some of the primary challenges. Like why don't you see a marketplace for virtual goods in most of these big free-to-play game economies that have thousands of items in a lot of cases, and an incredible amount of value, in some cases billions of dollars worth of digital assets in among player accounts. So we're trying to assemble a platform of tech and tools and in some cases operations like market making that equip game developers with the ability to do this as far as they're comfortable with it, and kind of run experiments in existing free-to-play game economies, some of which are already embracing marketplace-like designs and taking the risk and difficulty on themselves of being the middleman, and in some cases just not doing a very good job of it, really kind of locking it down to narrow interaction. So this is our partners at Spring. We put a fund together that its primary purpose is to get game developers to give this stuff a try, because most of the game industry is really not paying close attention to the potential that blockchain unlocks. They're still kind of focused on, can I get distribution that's cheaper? Can I build an economy that's deeper? Can I just kind of come up with the next design that consumers will take to? So we think there's a lot of potential to grow the game industry further in equipping them with these sorts of tools, but even more so to build the kinds of tooling that will run all kinds of virtual economies and make markets around digital goods that I think will be applicable well outside of games. So this is kind of a survey of the stuff we're building and how we think about it. It's primarily layer 2 technology. We're building portable side chains that will basically each game will have its own side chain and suite of smart contracts for doing things like minting NFTs. We're leaning on token bonding curves, which we'll get into for setting a value, or at least a floor on value in a lot of the stuff. And this is what we think game developers need in order to offer the quality of experience that is competitive today. So this is a big effort, but yeah, let's get into how. So this kind of back half of what I want to cover is really focused on it's a big challenge to get game developers to move from thinking just like merchants selling kind of a goods and having a total monopoly on their market of players to thinking more like almost like central bankers of their game economy and good custodians with like what levers do you have to pull to address things being out of balance? What corrective mechanisms do you have in the network of players playing your game if all of a sudden you see like a run on a particular currency or a liquidity crunch? So we have a handful of different angles that we're trying to put together to make all this very resilient and long-lived way to build game economies. So the first big piece, how many of you are familiar with token bonding curves? Probably most of you. Okay, maybe just nobody, almost, except Danny. So token bonding curves are basically a collateral instrument, and they're used for a great deal of market making already, automated, decentralized, hands-free market making. There's a handful of contracts called Uniswap, if you're familiar with them. There's a protocol called Bancor that's sort of built around this core idea. But there's some really interesting potential unlocked by using what seems to be a really simple instrument right out of the gate. You basically get a curve, and as you commit collateral to it, you move the price in one direction or another. So you can be on the buy or sell side of this, and you expect to see some slippage, just like you would in any market making activity. But it's actually deterministic and sort of always on, always available. So all sorts of ways you can take this construct that can serve as an automated market maker and make it run game economies in a way that would otherwise be incredibly difficult. So you can imagine you get a new game launches, and if you played free-to-play games, you see most of them have now more than one currency in them. They've probably got a handful of different currencies that interact with each other in some swapping way. Some of these games support composing these currencies into different items with crafting systems and making all this work together in a way where if you have players equipped because they have blockchain wallets and the assets are sort of permissionlessly available to move between players, then you need a value signal that you're not going to have on day one. You're going to have cold start economic problems. So having liquidity and cold start economic problems out of the gate for games that already need to have a very deep and complex economy is a huge challenge. Like traditional market making would not suffice in most cases for even one game. So having a tool set that supports really anything game designers come up with it kind of requires automating the market making and pricing of a lot of these goods, which isn't going to be perfect, and it's probably going to have big spreads or at least an interesting floor. But again, the bar right now in the games industry is you spend all this time and energy earning this stuff, sometimes buying stuff in these games, and that's it. It's sort of stuck there forever. You don't no one to send it to for free, no one to sell it to, and no one else to buy it from other than the game publisher. So having this bonding curve construct gives us a lot of options. And again, automated liquidity is a big part of it. One of the challenges in it, if you do some research on token bonding curves, you see a lot of them are pretty simple formulas. There's like Uniswap uses kind of family of market making formulas called XY equals K market makers. So it's sort of just like an inverse curve, and it has some advantages. It's really easy to compute an integral on chain, and it's pretty easy to figure out what kind of slippage you're going to get if you've got a thinly traded market that's likely to move in big directions one way or the other. But a lot of these commonly used token bonding curves don't actually mirror the way that economies and systems grow and mature over time. So we've been looking at sigmoidal curves as an interesting option out of the gate, which have this sort of exponential start, and then kind of through the period of most rapid growth, they respond in big ways to volatility, to changes in supply and demand, and then they mature. They kind of approach a horizontal asymptote, and so these end up mirroring the way systems grow and evolve much better than most bonding curve constructs that we see people using. But they come with, using these comes with some further challenges. So in one case, it's really hard to figure out how to set the parameters for this out of the gate. How big is your crafting material in your game going to be? How much demand is there really going to be for it? How much does it need to grow over time? Figuring this out over and over and over again without the ability to respond to what's happening in the market in a kind of more coherent way is pretty limiting. So a big part of our work is focused on parameterizing these curves in such a way where you get kind of a control back into the system by smashing the curve this way or moving the inflection point this way or that way to respond to a host of useful market feedback signals, transaction volume, overall volatility. So we're experimenting with a lot of this stuff right now, and there's really good work being done in the space by quite a few people who are thinking in public. So it's worth digging a little deeper into if you're curious. All right, so this is a framework I mentioned, which is a little bit of a jump, but this is really this is the best thinking that we've sort of stumbled across, refined, considered ourselves for how to evaluate how to apply things like a market feedback mechanism to the way a token bonding curve is parameterized. So you can kind of think of it like, I don't know if anybody here's kind of got a background in control theory or that vein of math, but you can kind of think of these signals as defining a control and giving your network the ability to recover from being out of equilibrium, being attacked in a variety of ways. And in most, in this framework, which again is not our work, just we think it's some of the best in the space. Most network designers really stop at efficiency. So design for optimality out of the gate. You hope there's some product market fit that you're going to design your way into, and the network's going to be utilized in a way that adds value. You hope it's going to be stable in the sense that the protocol is sort of designed around the way you expect participants to be motivated and incentivized to interact with it. And you hope it's efficient. You hope it's got enough transaction throughput to handle its use case, enough security, et cetera, all the classic trilemma of blockchain trade-offs. But almost no networks take the next few steps in considering how to build really robust designs and designs that can handle getting way out of equilibrium with some at least confidence or even guarantee of being able to recover. You can see this right now in the biggest blockchain network that we all know in Bitcoin. There's no way for that network to really recover being way out of equilibrium. If the price starts to go way down, miners' incentives move the wrong way, participants transacting value on it, their incentives are to trust it less and to value its units less. So this is really important stuff in trying to figure out how to make sure a network can survive big impacts, attacks, and just the unexpected when you have a really complex multi-agent system. So we really try to design around these pieces, and this is part of the thinking we need to impart on the games industry if they're going to do a good job of encapsulating these player-driven economies with the tech and tools we're offering. So again, this is just a little bit further into the vein of the vein of applied game theory to the way these networks function. If we're going to actually deliver on robustness and persistence in a big way. We think that this vein of applied engineering and math is the most useful way to take market feedback signals and to make, whether it's through your parameterized token bonding curves or through other instruments designed into your network, get those feedback signals back into your network. So let's jump forward a little bit. So again, yeah, what would the controls be in a game? You might have a rewards function for players or for networks of players inside your game that respond to things like how much supply of a game currency are you seeing locked up or transacted in a network? How much volatility are you seeing for demand of a given item, and giving these economies, curve by curve, or in total, the ability to respond to this stuff is really it's an optimization problem, and this branch of math and engineering, optimal control theory, is we think at least the best framework to steer toward the solutions that will give the best robustness and persistence performance, or at least expectations of performance. So this can go much, much further. This is kind of like way on the frontier of some of our thinking, but this is the way we think offers the most. We think this branch offers the most promise for designing these networks in a way that you can evaluate with simulations, eventually emulations, and discover what controls that you might introduce to these networks are going to give you the best long-term performance, are going to satisfy the Presto framework merits of these networks, and eventually you get, if you can kind of bound in a state space representation, if you can bound the possible states that are sort of allowed and policies in a way that, again, is familiar to a lot of other control theory applications, you can actually prove and you can provide guarantees around having an optimal control. In other words, like a feedback signal that is most likely to get a state back into your desired equilibrium. You can build energy functions sort of to repel the state the state space representation of your network being not where you want it. You've got massive deflation or extreme volatility. You can do a lot with really very well proven tools from math to evaluate this stuff in the first place, and to, I think, eventually design the best network that we know how at the moment. So happy to take questions. I don't know, I think we're a little short on time, but
Brett, thank you for opening the hood there on something that seems to lack complexity. I guess it makes sense that a complex new technology can be applied to these complex economic and game theory problems.
Yeah, I mean, it's really well proven tech tooling. Again, there's I'm sure people in neighboring buildings that are working on applying this branch of math and engineering tooling to problems that are way less consequential than running a game economy well. So we think this is a good sandbox to refine those tools for the way networks run on blockchains.
Amazing. Thank you very much.
Yeah.